Give us a little bit more insight into how Orion fits into the bigger picture, we have NASA's Associate Administrator for Human Exploration and Operations, Bill Gerstenmaier. Thanks so much for joining us, Bill.
Thank you for having me.
All right, well, why don't we start small and work our way out? How does Orion's test flight today fit into the bigger picture for just human exploration?
Okay, so I guess the way I kind of describe it is this is the first chance we get to really see the Orion systems really tested in the flight environment, and that's pretty exciting because we spend a lot of time in labs and simulators making sure all these things are ready to go, but you really never know how the vehicle's going to perform until you really take it to flight. So we'll get a chance to see a lot of exciting things during ascent. We'll get to see the service module panels come off and see if that works the way we've anticipated. We've done tremendous testing again on the ground to make sure all those work. In fact, we made some design changes to those very panels to help ensure that they would separate correctly. But to actually see it during the ascent environment and see that occur correctly and provide data back to us, detailed engineering data, is really, really critical and important. Also, the abort system, we'll get a chance to see it separate off the top of the capsule, and that's another critical function that has to occur in flight. We'll get a chance to see how that actually occurs in flight with the actual loading conditions, the ascent environment, those kind of things. So those are tremendously important. Then the vehicle goes into space and essentially is doing these two orbits around the Earth. Again, you'll get a chance to see all the avionics systems, all the software that will be used when crews fly on this vehicle. All that gets tested. It's basically the same stuff we'll use. Maybe some of the redundancy isn't there that will be there with the crewed vehicles. The life support system's not there. The crew seats aren't there. But other than that, it's the real vehicle that will be there with crew. So we'll get a chance to see all that work and operate. We'll get a chance to see the high radiation environment as we swing through the Van Allen belt, get to see how the avionics works, see how the software works. Again, just a tremendous test of the systems. Then reentry has been described by Rob and others earlier today. All the parachute activities, we'll get to see those. Look at the heat shield performance and make sure all that works. So again, it's a tremendous exciting time when you see all this activity that's occurred over multiple years kind of all come together into this test. So this is like taking your big final exam for in college or some major event in your life when you have to, it's showtime, it's time to, you've prepped, the team's ready, the vehicle's ready, Delta's getting ready to take us into space. So it's exciting seeing it all come together, and it'll be great to get this data, and then that really sets us up then to start using this vehicle then with crews in the future.
Yeah, I guess that's just a couple of missions down the road once we've got the space launch system up and running and or have it to send Orion farther into space.
Yep. And so again, the next flight of Orion would be with the space launch system, again on an uncrewed flight, but this time we would take Orion to a distant retrograde orbit around the moon, and then again check out all the systems. It will be there with an active service module at that time being built by the Europeans, and so we'll get a chance to see all that activity. So it seems like a long time from where we are today till 2018 or 2017 when we're ready to have CSLS and Orion fly again. But if you look at all the work that has to fit in that time frame and all the activities that have to occur, I guarantee you the teams will be busy. Many activities have to occur. You can see the SLS coming together down in New Orleans. You can see the main engines will begin testing next year down at Stennis. There's a solid rocket booster firing for SLS next spring in March. So again, just a tremendous amount of activity. So I think what we need to do for you, Brandy, is we need to make sure that you get a chance to participate and get the broader public to see these little events that typically occur behind the scenes, so you can get a chance of what's going. So it's not just one mission and then 4 years later it's another mission. There's continuous activity between this flight and with the next one, and maybe we need to let folks kind of see and get a peek of what we get to experience on the engineering side as we go through all these tests to get ready to make these things happen.
Absolutely. I'm sure the people watching at home would love that. But so that's how I guess today's flight test fits into the human exploration picture. Then how does the human exploration fit into the broader NASA goals and mission?
Yeah, you're seeing a lot of integration between the various mission directorates at NASA. Today on the Curiosity rover that's approaching Mount Sharp, it carries a radiation monitor, and the reason it carries that radiation monitor is really to understand what the radiation environment will be on the surface of Mars when we take humans there. So we're working with the Science Mission Director to do that. They're working on a new rover, a Mars 2020 rover, And on that rover, we'll carry a device that will take carbon dioxide from the atmosphere of Mars and actually pull out oxygen and actually generate oxygen into a bottle. And the idea there is we can then prepare for humans to have oxygen for them to breathe when they come and make sure that all that works. And oxygen is also a component of the propellants. It's the oxidizer that goes along with the propellant for the ascent stage. So this is another chance for us to get to prepare. So we're working with the Science Mission Directorate to see what they can tell us about the planet, that we can figure out what we can do to go get prepared for Mars activities. And what's unique about Mars is, it has a relative humidity, so it actually has some moisture in the atmosphere. It definitely has moisture on the ground. We can see ice get formed and evaporate. So it has many components that we can use, so we don't have to carry everything with us to Mars. So it'll be exciting to figure out what we want to use from the planet as we take crews there. But again, I think our first steps with Orion and SLS will be into what we call the proving ground of space, and that'll be around the moon. The idea there will be, again, to gain some experience of starting to break the tie with our home planet a little bit, and to take those risks associated with being now days away from returning and the moon. So it's an exciting plan, and we're on station today, and station fits right into this whole stream of things we talk about. We have crews on orbit now learning how the human body performs in the microgravity environment. We're tearing apart the carbon dioxide removal system on board space station as we sit here today. They did it yesterday. They cleaned some dust out of it. Then it failed a leak check, so they're going to have to go in and then probably change a seal and do some things. But what we're learning there is how we maintain these systems that will have to operate for multiple months to years as we go to Mars. So those systems we're testing on station, those are the systems that will be used to go into exploration and go to Mars. So as we're preparing, it's kind of neat to see the synergy. The other thing that's also really unique is we have an instrument on board station, RapidScat, that measures sea winds. And they're actually using the data from space station to provide wind conditions for the landing team here for Orion. So here's space station and the Science Mission Directorate's wind measuring device actually giving data to the flight control teams here to actually do the Orion test flight in the landing conditions at the landing zone. So if you talk about the agency working kind of as a total team, that's a great example of how all the directorates and all the folks all work together to accomplish these great missions.
Yeah, I think it's kind of amazing how all the puzzle pieces fit together.
Yep.
Well, thank you so much for joining us. We really appreciate it. And I think now we're going to focus back in on Orion's flight test today with a look at the trial by fire that's coming up. The final launch coverage, NASA Administrator Charlie Bolden here to tell us a little bit about how he's how he thinks today is looking, and how this fits into the bigger picture for NASA.
Well, Brandy, thanks very much for letting me come on with you. It's a big day. I've told people that over and over, and today is sort of a continuation of what NASA's been doing for a little bit more than 40 years now in terms of Mars. Mars has always been humanity's ultimate destination. It's where even the science fiction writers wanted to go. And so from the earliest time with Viking, the other Mars landers, Maven in September, we've got InSight coming up in 2016. It's going to core into the Martian surface, and all of those are robotic precursors helping us to prepare to send humans to Mars. From the human standpoint, today is like day one. This is, I would describe it as the beginning of the Mars era, if you will. We went through Mercury, Gemini, Apollo, that particular era where we culminated with the landings on the moon, and then we shifted over into shuttle, where we began to build the low Earth orbit infrastructure that everybody knew was going to be necessary if we were really serious about exploring, about deep space exploration, because you can't keep coming back to the planet. You've got to be able to have an infrastructure in low Earth orbit, and then at one point we want to have an infrastructure around the moon, sort of a staging base where we can go on, and that's what we call the proving ground in NASA's exploration strategy right now. So this is day one of the Mars era. When Bill Gerstenmaier talked to you earlier, I think he mentioned the term like trying to be Earth independent. Right now, we consider ourselves to be Earth dependent. We're hours away. A couple of hours if a crew member has a real serious problem from deciding to deorbit them and get them back to a place of landing somewhere where we can get them to emergency facilities if need be. When we move out to the moon again, we're going to be in a position where we're 2 to 3 days away. if something happens. So that will give us an opportunity for 5 to 10 years to work in the lunar environment and cislunar environment, trying to really make sure that the technologies that we have are as good as they can be, that they're very resilient, that they're very reliable and very dependent, because unlike today where we can, we launch a spacecraft every 2 or 3 months and it takes spare parts. When we're going to Mars, we're talking about being away for 3 years. It's just 8 months right now to get there, so there's no taking spare parts and the like. Pumps have to last forever almost, and everything, and that's what we intend to use. We're using the International Space Station right now as a development facility, also using it primarily to study the human body, how it interacts with the environment in microgravity. And then when we get to the proving ground in lunar orbit, we're going to do some more studies, learn a little bit more. If we're lucky, someone will come along, whether it's an international partner or a commercial venture or an entrepreneur, and will say, look, I'm serious. I really want to go to the surface of the moon. Can you guys help us? And we're going to say, yes, we can do that. Bill may have told you that. We've got incredible capacity with the SLS when it's operating. We can take our crews, put them in cislunar orbit, but we can also take a lander for some other nation or for a partner, put them down on the surface of the moon, put a couple of NASA astronauts with them so we can do some studies, learn things like you've heard us talk about the increased intracranial pressure, that problem that squeezes on the optic nerve and causes an astronaut to have visual acuity problems. Is that a microgravity problem? Is it just a problem of 0G, or is it something of less than 1G? You don't want to get all the way to Mars and find out that it's not microgravity. It's anything less than a G. It's anything less than the Earth environment. So we would like to put astronauts on the surface of the moon to study things like that. We don't want to leave anything to chance. So we've got a matrix of human research things we want to get done. We think we'll have them finished by 2024, 2026. So there's no magic in wanting to extend space station to 2024. It's just when we lay out the matrix of things we have to do, technological challenges, understanding the human body challenges, they all run out to about 2024, 2026. So we critically need the International Space Station till then. Then we're going to shift to doing things around the moon, where we'll use that for another 5 or 10 years, and then finally sending humans on to the surface of Mars eventually. That's the ultimate goal. But again, like my granddaughter tells me, don't get hung up on Mars. Because there are other places to go once we get there. So for dreamers and people who want to think really big, Mars currently is the ultimate destination of this generation. But once we get there, we hope that the technologies for propulsion will have increased. We'll no longer be stuck with chemical engines and the like. We'll have nuclear power. We'll have ion engines and the like that can speed us from one planet to another in a matter of a few months instead of 8 months to Mars, 10 years to get to Jupiter or Pluto or things like that. So the future is really bright, and it's the young people right now who are dreaming about what they're going to do. They're really going to make the difference for us.
Well, hopefully some of them are watching today, and we have
I sure
sounds
hope
like
so.
a lot to look forward to on the journey to Mars.
They do very much so. So thanks very much for letting me spend some time with you. Thanks to everybody who's tuning in and listening. Hopefully you're as excited as we all are this morning, and hopefully you'll be about as giddy as I am. I'm nervous. So I always get nervous anytime I have to go out in public, and I think that's a good thing. So I'm feeling good.
I agree. So we're going to go back now to Mike Curie for an update.
Thank you, Brandy. Thank you, Charlie.